Okay, so hi everyone. Today we're going to talk about another problem, that is LeetCode 328 odd even linked list. And it's a medium level problem, although it's a good level problem. I will say that it is an actual medium level problem. And the size, the like to dislike ratio is very prolific. So let's start this problem. We are given the head of a singly linked list. Okay, so we are given a linked list, right? Group all the nodes with odd indices together, followed by the nodes with even indices, and return the reordered list. The first node is considered odd and the second node is considered even. Fine. Which means all the nodes that are shaded with red or pink background are considered as even nodes, and they are grouped together. So 2 and 4, they are at the last, and the relative order should be maintained. And it is written that note that the relative order inside both the even and odd groups should remain as it was in the input. Okay, so first of all, let's see what this problem is. So we are given this as, this is the first node, and then this is connected to 2, third, fourth node, and we have fifth node, right? So if we have to write down their indexes, it will be 0, it will be 1, this will be 2. Wait a minute. Yeah, it's not 0. So the indexes are starting from 1, 2, 3, 4, and 5, right? And the odd nodes, so what will you consider? Okay, so which are the odd indices? So 1 is an odd number, 3 is an odd number, and 5 is an odd number. And which indices would you consider as even indices? So 2 is an even indices and 4 is an even indices. So if we have to group them together, then the odd indices will be 1, and then we have 3, then we have 5, right? But after that, we have to group the even indices together. So now we have 2, then we have 4, right? And this is the head of the linked list that we'll be returning, and this is the reordered linked list, right? So this is the output, right? 1, 3, and 5, and then we have 2 and 4. Perfectly makes sense. Now how we can solve it? So one, a very default method of solving it could be, which I think must have come through your mind after understanding the problem, is that why not store all these values in a vector, right? So we have 1, 2, 3, 4, and 5. Okay, after that we can iterate over this vector, right? And we can iterate over the alternate elements. So let's say I start with 1, then I start with 3, and then I have 5. So I will create 1, 3, and 5. Then I will do another iterations, and now I'm pointing on the last node, and then I will do another second pass iteration in which I will have all those odd indices elements, because this is 0, 1, 2, 3, 4. So now I will start with odd indices. So now we have 2, then we have 4, right? This is one way of solving it, but and I think this is the only sufficient way of solving it. You can also follow another pattern of creating nodes, right? You can create two different nodes. So you have one index that is an odd head, right? And then you have an even head. So in odd head, sorry for that. So in odd head, you will start iterating over these nodes, and you will look for the even indices, right? Because in a vector, the indices is, it's a more, by the default implementation, it's a zero based indexing. So because of that, for odd indices nodes, you will look for even indices in a vector. So you will say that, okay, 0, 1 is an even index, so you will have 1 here. Then the next node is an odd number, so you will have it odd place, so you will have 2 here. Then you will have 3, and this place you will have 4, and at this place you will have 5. When you are pointing on the last node, then and the next node is null, then you will make a connection between these two, and now this node is looking something like 1, 3, 5, and 2, and 4, right? I hope you have not skipped this part, because this is an important part in order to generate um the constant space solution. Now one thing is very sure, that our time complexity will be linear no matter what, right? Because we have to iterate over each and every element in order to concatenate or reorder them. But can we optimize the space complexity? Yes, we cannot. Yes, we can, because it's also given in the question. And if you are in an interview scenario, then the interviewer might give you an follow up after this approach of a vector. Then an interviewer will give you a follow up that can you solve it in a constant space? And yes, we can. How we can solve it in a constant space? So we have two methods. So one method is insert, and the other method will be connect odd and even node. So this method. So now let's talk about the first method, that is insert. So I have 1, 2, 3, 4 and 5, right? So what I can do is I will have a first pointer here, or let's say this is an odd pointer. So no, this is an yeah, this is an odd pointer and this is an even pointer, right? Let's just be O and E. And the third pointer you will have is T. So this is the traversal pointer T. Now odd and even, right? So T is pointing on the, so on the first pass I will say that T value is pointing on the third element, and third should be grouped with the first element, right, with the odd element. So I will say that 1, I will say that 3 should be placed in this link, which means that this node will look something like this now. 1, and then we have 3, then we have 2, and now 3 is gone, so we 2 is connected to 4, and then we have 5, right? Now what about the pointers? So odd pointer is now incremented because this is the last sequence of odd pointer, and we have even here, right? So even should also be incremented because fourth is now the new even pointer, because we are very much certain that after T, whatever the index that I have will be directly connected, should be directly connected to the even list, should be directly indulged in the even list, right? Or inserted into the even list. So we are not going to bother about that, and we are simply going to move our even pointer on the next part as well. That is after 2 it was 3, but 3 is gone, so after 2 we have 4. Now E is pointed on the next element, that is, so E was basically here, and the E next is so E is pointing on the E next, that is 4, and T should be pointing on the E next, which is 5. Now at this point I will again make this change. And what about this change? So I have to change, so what do I have to change is this link, right? So 1 as it is, 3 as it is, but now 5 is inserted, and then you have the list as it is, 2 and 4, right? Now what about the pointers? So the pointer odd is pointing on the fifth element because that is the newest inserted element, and even, so even was pointing on 4, but now it's pointing on the null part, right, on the null node, or let's just say null. So now when we say that the even is now pointing on null, the whole list is sorted, not sorted, reordered in the way we are requiring it, and we are done with our answer, and then we can return the head, right? And that is one approach. So let's see this approach, and then we'll talk about the other one. So for this approach, you need to check first of all if you have, because in constraints it is given that there can be 0, 1 or 2, 3 nodes. But if we have only, let's say we have 2 nodes, or let's say we have 0 nodes, we are going to return null, right? If we have 2 nodes, it cannot be reordered, so the default order will be returned, which means we need to return head. And if we have 1 node, again we have to do the same thing, return the head only. So if head is equal to null, or head of next is equal to null, or head of next, which means that there are only 2 nodes, is equal to null, yes, then simply return head, right? Now I will be creating some pointers. So first is odd, let's say odd head, and that is pointing on, so odd head is pointing on head initially. Then I have another pointer that is even head, or let's say odd tail, yeah, that will be a better name for this variable. And this is even tail, because basically this pointer is always on the tail of the even or odd linked list, right? That is why we are using even tail, odd tail. Now this is pointing on head of next, right, the second element, and we need a pointer for iteration, and that is equal to t, and t is pointing on head of, yeah, so head of next. Now you don't need to worry if this will give you a runtime error, because head of next means third node, and by this base condition we are verifying that we have at least three nodes, because if there is no node, right, then it will be return head, and if there is only one node, then we are going to return the head as well. If there are two nodes, then we are going to return head, but if there are three nodes, then we are going to follow this code. And yeah, so this is t. So now what I will do is I will have a condition while even head, right, because even head was the one who is crossing the part. So while we have the even head, what we'll do is we will simply, so first of all I will change some pointers. So when I'm pointing on, sorry, not second, so it's actually even head. So let me write this code and then I will explain you what I'm doing. So even head of next. So when I have this linked list and I want to change this part, right? So this pointer, this node is gone now, right? Which means this node should be connected to this part. For that purpose, I will write even head, that is this even head should point on t. So t was here and the t of next, that is 4, should point on t of next. Okay, this is done. Now t of next, now t is a node which we have extracted out, which is the third node, and it is now pointing on this element again, but this pointer, this link should be done in this way, right? So this is now pointing on 2, which means t of next is now equal to odd head of next, right? And odd head of next is now pointing on this the t of next, right? So this should point on t, and in this way you can see this node is more like this linked list, and this linked list can be easily observed as a straight linked list, right? So this is now inserted, which means the t node is now inserted. So the odd head of next is now equal to t, and now odd head is equal to odd head of next, and even head of next, right? Now what about t? So we need to give the value to t, but there is a option, there is a chance that even head is now pointing on null variable, right? So in order to check that out, we can simply say that if even head exists and even head of next, so we don't need to check the even head of next, we can simply say that if even head exists, then t should be equal to even head of next of even head, otherwise simply point on null, right? And yeah, so after that we can return head and we'll be good to go. Okay, we are using even tail, so even tail, and this is odd tail. Okay, let's add one more test case. This time we only have, let's say, 3 elements. Okay, it's working. So let's try submitting it. Okay, so we have an issue. Yeah, okay, okay, yeah, I should give it a scenario that t is also null, because at this case t would be null and we will get out of the loop. Or I can also say even tail or even next, right? Because that is where the t is pointing on. So I can say even tail of next should also exist. Yeah, and it is not performing very good. Okay, so anyways, let's see another approach. Basically, the time complexity of this approach would be linear, right? And space complexity is constant because we are not using vector, we are only creating, 3 pointers. So it's definitely constant space. Now let's see this approach. So this is a very interesting approach. So we have 2, then we have 3, then we have 4, and then we have 5, right? So this approach says that why shouldn't we connect all the, this earlier approach where I was using this iterating in a single pass, I was creating a linked list, right? So why shouldn't we uh, change the links of the linked list to their next one, right? So this is an odd node. So let me write down their indexes. So this is 1, this is 2, this is 3, this is 4, and this is 5, right? Now 1 should be connected to 3. Fine. I will say 1 is now connected to 3. And then 2 should be connected to 4. Fine. I will say 2 is now connected to 4. Okay. And we move further ahead. So we have 2 pointers. So odd and even, right? Now odd is change and even is change. So odd will move ahead and then even will move ahead. So sorry, odd will move 2 times ahead because this otherwise it will point on an even element. So odd is now here, and even also has to move 2 times ahead, otherwise it will point on an odd element. So even is now pointing at this point, right? So even was here 1 and 2. So now odd pointer should be changed. So this will be like this, and the next of next odd, and the even is changed to the next of even, which means not 5, null value, and this is now pointing on a null value. Yes. So this is the approach, and when we are done with it, yeah. So when we are done with it, now odd is going to be here. So odd of next is going to be pointing at this point, right? And we need to connect this linked list, that is 1, 3, and 5, to the even indices linked list. So I will say that. So I will store this value, that is the even head value, and then I will connect this to the even head value, that is 2 and 4, and that is okay. That is not my answer. I I need to create another. No, that is my answer. Okay, fine. So this is the linked list that we want. Now let's implement this. I think the logic part is very clear because it's not that much of an deal, I think. So I'm directly jumping on to the implementation part. So first of all, we need to take a even head as the, you know as a record of the even indices linked list. So this is head of next, right? The second node. And then we have odd node. This is equal to head. And then we have even node. This is equal to head of next, right? The second node. And my while condition will have these values. So while odd node of next and even node of next exist, right? Both of them should exist, because in these cases where we have 1, 2, 3, and 4, when we have this case where we have even length of nodes, then this link should be changed to this one, and this link would be changed to this one. Now this link wouldn't be changed because this is odd, this is even, right? And now we are done with it. So odd is pointing here and even is pointing here. But after this case, odd is now pointing on a null part, right? And even cannot point. So odd value is something which is getting degraded at first in an even length linked list, which is why odd is on the first side. So if we don't have odd next, then don't do anything. So we are checking it first, and then check the even node, because if this is taken at the as a null part, right, and even next of next is null, so even next is null, and null next, when accessing null next, will give you a runtime error. In order to deal with that runtime error, we will be checking the odd next first and then even node next later. So now we have odd node of next is equal to odd node of next, and we have even node of next is equal to even node of next, and then simply move the odd node to the another odd index, and that will be odd node of next, sorry, next only. And same for even node. Now when we are done with it, we are not like done with the whole program. It's still the, because we have created two separate linked lists. So one is the even indices linked list, and another is the odd indices linked list. Now we do have we do have a pointer that is pointing on the last part of the odd indices linked list, and that needs to be connected to the even linked list. So that will be even head, right? So the value that we have stored earlier, and then we can simply return head. Okay, it's working, and it is also not performing that well. I don't know, man. uh it's basically the same algorithm, and still it's not performing well. I have no idea why it's not, but I think it's acceptable. Yeah, space wise it's good. Okay, so yeah, this was the solution, and the time complexity for this solution is also order of n, and the time complexity for this one is order of n, and space complexity is constant. For this one, space complexity is also constant, and this is time, and this is time and space complexities. So if you want to find the source code, you can find the source code in the description. And thanks for watching. Have a good day.